AC in and try to probe the outputs with my meter leads. Looks like a pretty small connector. Don't know if I can get in there. Yeah, it's gonna be tight. Let's break it open and get to the inside. Get a better look. Just pry the cover off. This one has a snap-in cover, so it's easy. Some of them are glued together, which are probably more difficult. AC applied, green LED on the output. Looks good. Yeah, it's on, I can tell. Okay. Let's verify. Just gotta flip it over on the bottom side so we can actually get to the actual solder points. There's no access from the top. Black and white wires. Let's take a look in the output. Meter set at volts, DC. Flip the leads around. Flare the diode. Yeah, power supply works, 24.18 volts. Seems good to me with no load. Let's check the continuity of the wires now. Let's see, I think this connector comes apart. Let's try that. Alright, there's parts coming out, and there's a little nick in the cable right there. You see it? That could be our problem. It's right at the bend, too. Gotta get the rest of these guts out of this connector so we can probe the end of the connector. There we go. There they are. Now we have access to the whole thing. Ohms on the meter. And we'll check the continuity of the wires. Let's see, we'll go with the black one. The bottom of the board. It's got continuity. Turn that TV off and listen for the beep. Beep. There it is, continuity. Now let's check the white one. And nothing. Nothing there, nothing there. It's not shorted to the black one. There we go. White wire, nothing. So I guess that problem is there. In the cable, not the power supply. Black works, white doesn't. Let's check it from the connector end. That's where we suspect the problem is anyway. Other side of the connector, good. To the brake, nothing. Let's open it up a little bit. Nope, no go. Try it from the other end. White wire goes to that side of the diode. Almost. But when you flex it, it loses continuity. Definitely our brake. Let's cut that over there. Oh, got continuity there, but we'll have to cut it anyway. And away it goes. Now we just have to strip it back and resolder that connector. Don't want to nick the wire though, so make sure you always strip at the right size or just one size above. if you nick the wires, there's a potential for a short, or if it's AC, shock. Don't want to break any strands off either. You want all the strands that are in there. Let's pre-tin these wires after we check them to make sure we got continuity. If that's not broken somewhere else. That's good enough for me. Not sure it out, that's good. Little helping hands here. A couple alligator clips and a piece of wood. Keeps everything steady. Gotta twist these together a little bit so all the strands are nice and straight, and then pre-tin them so that they grab the connector easy. You don't want to overheat the wires because they do melt the insulation. And if you overheat the connector, you can melt the plastic and then it won't fit back in its housing. So you don't want to stay on there too long, just long enough to melt the solder into it, and that's it. Now we got to take the wires off the old connector. Again, just long enough to melt the solder and pull the wires away. Remember the orientation, black on top, white toward you. You have to trim these back a bit, they're longer than I thought. There we go. Black wire away, white wire toward you. Just long enough to melt the solder and the connector pin, but not the plastic or the insulation off the wire. Yep. Now let's check the continuity and make sure we got a good connection. Seems alright to me. Verify the other side before we button it up. There we go. Now we plug it in and see if 24 volts come through the connector. Of course, you got to change your scale on your meter back to volts DC. Plug in the AC power cord. There you go, 24 volts on the connector, like it should be. Alright, let's button it up. We're done. We'll give Willie back his power supply and tell him it's fixed. No need to buy a new one. Alright, slide this back together. Let's see, this little metal sleeve seems really close to the white conductor. There's a little solder bump there. We'll have to take care of that. Don't want it to short out. Try to flatten that solder bump out a little bit with the soldering iron. I think we'll have to add a little solder to the iron because it's not heating up. The connection, that is. The iron's plenty hot, just isn't heating up the connection. A little dab of solder would do it. There we go. Let's take a look at that now. it seems to clear now. It's not going to short out. I think we should insulate that though, just for the hell of it. Just in case. Never hurts to add a little bit of insulation. Yeah, a little bit too big. Let's cut that in half. Go. Use a small part. Wrap it around the wires. And now the metal part will not contact the wires. And it's still free to rotate when it has to. Back in the plug. All the parts are still on the cable, which is good. It means they didn't fall off. Don't have to unsolder the connector again. Carefully put it all back together and screw it on. All done. Alright. Don't forget the power cord. You're welcome, Willie.